terms worth of data up here. Let's use this and see if there's any difference. Let's use the big red curve to see if there's any difference. So let's play in the home game. There she is right there. Back it up a little bit. All right. So let's swing back over here, and we can reuse everything we've already got. Just we gotta change L2, don't we? We gotta change L2. And I'll make it easy for us because I actually have the data right here. Here's the cumulative data right here on the Excel sheet. So if I go into stat edit L2, it's 003, 16, 33, 33, 21, 11, 7, 4. That's cumulative data over time. Looks similar to ours? What do you think? Similar? How's it similar? Give me one way it's similar. It's not exactly the same, obviously. Veronica, go ahead. One way it's similar.
Bell shape.
Good! We got even more of a bell shape than ours does, because less all that kind of butterfly effect flapping is being smoothed out over time. Good. What else is similar? Say that again. 5 and 6 are equal, meaning that we've got, it looks like a little more data on the right side of 5, maybe. That average looks closer to maybe 5.5, maybe even 6. I want to run the actual one-bar stats here to figure it out. Good. If we were guessing, purely 5 would be the high point. We'd be tailing off from there. Good. So, let's find out. I want to hit graph. Oh, I probably have to adjust my window too. Window, I gotta go up higher now to say 40 by 4. Is that how I'm gonna do it? Not bad! Look at that. Look at the lack of outliers. Look at that! Hot damn! Half of your data lives between 4 and 5. That's or between 5 and 6. Very nice, very nice. No outliers. No outliers, but we've lost that clumping at 4 that we had in our data, which means it's smoothing out. Our 4s are now part of the overriding data set. Looks beautifully bell-shaped, just like ours does over there. No outliers. FYI, box plots are a pain in the butt to make in Excel. If anybody ever needs to do one for a presentation, let me know. We're going to learn in here later on in the course, but if you need one between now and the course, let me know. I've got an Excel thing you can fill in the blanks and get box plots. Good? I'm curious. Let's make the interval around it. Let's make the interval. Let's run the T interval again. T interval. Everything's the same. Our data's still in L1 and L2. No different. No different at all. Let's just see. Give it a couple seconds. What do you think? Is this evidence? Well, the overriding average is a smidge less than ours was, yes? Ours was 5.96. This is 5.69. So we're down a couple tenths of a guess, or a couple tenths of a correct response, but arguably the same, a little bit above 5. How's the margin of error different in this one than in yours? The perfect square number. I wasn't expecting that. It's exactly, the square root of that is exactly 12. That's very convenient. Actually, it's just convenient and random. It's smaller, yes? What's the margin of error, friends? The sample standard deviation is almost the same as yours. 1.8 versus your 2. It's almost identical. What's the margin of error? Yeah, right about 3/10, yes? Right about 3/10. So the reason I like looking at this one, your new data, if you were to slap it up here, it's essentially in the same place. It's essentially in the same center place as yours. But the wings have tightened up a bit, yes? So this guy right here is your class results. This is the over time results. This is n equals 144. And this guy right here is n equals 27. Which means we have a larger minimum measurable difference. It's about twice as big as it was before. It's about 0.4 now versus 0.2. Now again, people will argue that that's meaningless. Because if you round the nearest whole number, it's still going to be 5. Which would be put 5 in the interval. And I say, sure, I'm not trying to prove nor disprove anything here. I'm trying to see if something's worth seeing. What this tells me is, what does this tell me actually? Because this is probably the most important thing. You now have your results, and you get ready to tell somebody about them. Maybe publish them in a journal. what conclusion would you have at the end after seeing these results right here? Is your curiosity piqued?
Yeah.
My curiosity is piqued as well. What would you maybe recommend to your colleagues to do?
More research.
More research, more participants, better controls for sure, right? Better controls in the study. Because what does it appear is happening here? It appears as though the average actually is to the right of 5. And the more trials we get, it's tightening down around that average. Maybe it's 5.5. Maybe the average is 5.5 or 5.6 or 5.7. Maybe it's not a whole lot more than 5. But statistically significantly, it's starting to look like it's more than 5. Right? Depending on what you're round to, which is kind of a lame way of looking at it. But suppose you got the margin of error tightened down enough. So it was 5.6 up to 5.8. Well, then it rounds to 6. Yes? Then you can say, holy crap. It looks as though we have not just statistically significant proof, but arithmetically significant proof. I used proof the wrong way there. Support, evidence, that we're not just guessing that maybe something else is going on. That's what I find interesting about this. It's actually showing us something like maybe there is something there. But the only way to see it, it's like that joke headline I showed you guys in 243. The headline from Our World says, psychologists find surprising new findings, tout surprising new findings. And the mathematically literate headline should say, psychologists promise to replicate surprising new findings before they tout them. Exactly the same thing as what Veronica just said. Encourage your colleagues to go do the experiment again under the same set of conditions and see if they can support the same set of results. Because what it looks like over time and over time and over time is that every single class, I mean, here's the data. Here's each class's data. And this is why I'm excited to see it. I'm excited to see it change as time goes on. If you look at the data, it looks extraordinarily similar class to class. Which means we're basically hitting the same average class to class to class to class to class to class. So if that keeps happening, that means our sample size is increasing as we start collating it together. Which means your margins of error keep shrinking. The average stays the same, but the margin of error keeps shrinking down. That's kind of wonderful. That's kind of wonderful. Fair enough?
Yes.
All right. Let's take 5 and come back and do one more of these. Make sure we got it in the bag. Make sure we got it in the bag. I want to make sure we understand this. If you want to throw that in as a quiz, drop it on up here. Hi. Here she has the quiz.
Yes.
Damn it. Who else is partner didn't show up today? I imagine that's probably with a few people. Anyone else's partner not show up? Let's get you guys together, put your names on each other's quiz,
Okay.
and submit it. How's that sound?
Great.
I know it's the wrong data, but that's okay.
Okay.
That's why I was adamant on getting the data on
Yeah.
Tuesday to make sure that this doesn't happen. Good.